Good morning. Okay, let's get organized here. Okay, I'm starting out my talk with a disclaimer because it occurred to me that I was being videotaped and this is all going to go on the web, and I wanted to make sure that that I include a disclaimer just because as University of California researchers and extension people, we're not supposed to be making recommendations. We're just supposed to be giving you principles and guidelines. And I'm on a steep learning curve in terms of nursery. I normally work in just the commercial citrus situations, and I know all the labels and uses and how things work there. And the nursery situation is so much more complex that I live in fear and trepidation that I've probably made mistakes on my slides or might give some slight misinformation. So my disclaimer is basically you all need to be reading the labels and ascertaining with your, talking to your county ag commissioners about their attitudes about what defines these various structures and what is legal and not legal. So there you go. There's my disclaimer. Okay, we're about to have some huge changes in the citrus nursery industry. Come January 1, registered mother trees are going to go under screen and then, or under glass houses, and then in 2013, then the increased trees will be under screen. And when HLB arrives, probably a good part of the production trees are going to go under screen. So we have two sort of issues that I want to cover today. The first one is that how are we going to manage the existing pests in enclosed structures, because we're transitioning, and I say we as the citrus nursery industry, is transitioning from primarily outdoor to more and more indoor structures and more enclosed structures. And the rules and regulations for these pesticide labels are very different. And then secondarily, another issue is that you're going to be, as exotic pests come into California more and more, you're going to be required to treat plant material for these quarantine pests prior to shipping. And that raises a whole nother level of treatment and issues. So let's talk about some of these. Now, in polling some of the nurserymen, I think probably the top 3 pests that are common in nurseries are the mites, various and sundry species, the citrus thrips, and the citrus leaf miner in terms of your need to protect that new growing flush tissue from damage. And then there are many occasional pests, which you might also see, things such as various and sundry caterpillars, the leaf rollers, and things like that, katydids, aphids, whiteflies, various armored scales like red scale, brown soft scale, earwigs, snails and slugs, and ants, and things that are sort of cruising the ground in the pots. And you've got very different situations. Some of the nurserymen are growing plants in ground, some are growing them in pots, and some are growing them indoors. And each of these have different label requirements. So I'm going to go through some tables here, and my presentation will be loaded up on the web, so you'll be able to get access to these that way. And I've given you as a handout in my section sort of a summary of these with maybe a few less details. But I want to go through a couple of the groups of insecticides and just talk about some of the issues that are related to using those particular chemicals in citrus nurseries. And I've put across the top the chemical name, various formulations, because you might be more familiar with those names, the chemical group that they're found in, and within your handout I have the IRAC website reference where you can go and recheck any chemicals that you want to use to find out what chemical they're grouping they're in. The reentry interval, whether they can be used for bearing citrus, non-bearing citrus, in nurseries, and in enclosed structures. Very complicated. We have lots of different situations. Let me explain some of those first. Let's talk about bearing versus non-bearing. And I know that there are lots of, I would say, interpretations of labels going on at the moment. And I would just caution you that as we move into enclosed structures, I think that the interpretations of those labels and those sites are going to become stricter and stricter as we go along. For example, these are 2 different definitions that I saw on pesticide labels for citrus. Non-bearing would be a perennial crop that will not produce a harvestable raw agricultural commodity during the season of application. Okay, defines season of application. We can define that a couple different ways with citrus. And then I've also seen definitions such as this: trees that will not bear fruit or nuts for 1 year after application. That's a calendar year. Whether it's this season or next season, it's a calendar year. And I know with the regulatory treatments that are going on, the second definition is what is commonly used. So be aware that you can't just take a bearing tree and strip the fruit off and spray it with a non-bearing label pesticide and say, well, it's not bearing, so it's a non-bearing tree. Pretty strict rules on how to define these sorts of things. And then in terms of enclosed structures, I'm going to read you some of the regulatory language. The use site greenhouse is defined as a structure or space of sufficient size to permit entry that is enclosed with non-porous covering and used in the commercial or research production of an agricultural plant commodity. A structure constructed of porous cloth or other porous material such as lath is not considered a greenhouse. If a greenhouse has sides or significant portions of the structure removed during the application and restricted entry interval, it's not considered a greenhouse. Simply opening doors or windows does not alter the structural status as a greenhouse. Whether a specific pesticide may be used in a greenhouse or other enclosed plant growing area depends upon the application directions that appear upon the labeling. So just opening the doors doesn't change the label. It's still a greenhouse. Greenhouses right now are being built that have some porous material in them. They might have some screening vents at the top, but they still have solid sides, solid walls, and generally solid ceilings. And so those would be an enclosed structure and you need to utilize the greenhouse labels. Screenhouses are porous, so they could use any nursery label. So I created these tables because I'm looking at this as probably every single one of you has every single permutation of bearing, non-bearing, nursery, screenhouse, and greenhouse. And so you're going to have different labels for the different applications you make on your property. And it's very, very complicated, and you need to be on top of that. So that's my basic message here. So let's go through some of these and just talk about them for a minute. For example, we'll just start at the top. Ultiflora is milbemectin, which is a miticide in the group 6. It's got a 12-hour reentry interval, and it cannot be used on bearing plants. It can be used on non-bearing in nurseries, but there's no label for greenhouse. So it could be used in screenhouses or outdoors on non-bearing trees. Hexathiazox has a number of different formulations. It's in chemical group 10A. The reentry interval is 12 hours. Some of these formulations can be used on bearing, the onager, but the other two you cannot use it on a bearing tree. The non-bearing, when I put a little asterisk there, that means that the label talks about non-bearing fruit trees in general, but is not specifically listing citrus as one of those, but it's still available to use. And it is the only one that can be used that specifically has language for using it in an indoor enclosed structure. Okay, so you've got 3 formulations of the same chemistry available. Only one can be used on bearing. Only one can be used in greenhouses. Etoxazole, zeal, or tetrasan, similar kind of situation. Either of them can be used on bearing, but one of them can be used in the greenhouse. Now notice I've got these both colored in a pinkish color. 10A, 10B is one chemical group, meaning that if you were to use these 2 chemicals back to back, you would be selecting for resistance or cross-resistance in the insects because they're in the same chemical group. Okay? So one of the things I want you to be very aware of as you're starting to increase your treatments in these enclosed structures, because likely you will, because enclosure means intense pest pressure. We don't have natural enemies. You have very dense plantings. You have perfect conditions, growing conditions for both the plant and the insect. You're going to have lots of insects and mites, and so you're going to be treating fairly frequently. You need to be very aware that you're rotating different chemistries from time to time, each time you spray, so that you're not selecting for resistance. Okay, we'll go through a couple more of these. Phenbutadiene oxide and probarkite are both extremely old chemicals. We've been around a long time, Both of them are Category 1 chemicals, and they're in the same group. They have slightly longer reentry intervals. Vendex could be used on the enclosed structures, Propargite cannot. Now I've said NS. NS means not specified. It's not specified on the label if you can use it in a greenhouse or even in a nursery. It's just not specified. And I think a number of people, excuse me, a number of people have been interpreting that as, well, if it doesn't say you can't do it, then I'm going to go ahead and do it. I think that's fine to a point, but as I said, I think the rules and regulations are going to start tightening down, and I think you, especially for the enclosed structures, you better be making sure that the label that you're using actually has the word greenhouse on it or enclosed structure on it. That's where I think you could get into a lot of trouble. We have another product, Canamite, not usable in the nursery situation, really only for mature growing citrus, with fruit, the bearing citrus. Nectar and Fujimite and Akari are all in the same chemical category. Again, we have the situation where some are available for greenhouse, some formulations not, and some primarily for fruit trees, not citrus specified. Then we have this chemical group number 23, where we have Envidor and Judo. Again, we have greenhouse products and we have bearing tree products. And then finally, acromite and floramite, similar kind of situation. So when you look at this overall, we have 5 chemical groups available for bearing citrus trees. We have 7 for nurseries in general, and we have 6 for enclosed structures. So you do have a variety of insecticides, and you do have the ability to be rotating these different miticides to make sure you don't select for resistance. Now, obviously, some of them are more expensive than others, and that drives a lot of the treatment program. But I would say over the long haul, you need to be thinking in terms of rotations. Now I'm going to go on to the organophosphates and the carbamates. A couple of issues come up immediately. Quite a few of these are Category 1 materials, requiring extra protection and extra training. Quite a few of them have fairly long reentry intervals, 5 days, 14 days, depending on rate. And so that makes them pretty unworkable, especially in nursery situations, because you need to be getting in there at regular intervals for all sorts of issues of pruning and managing the plants and grafting and possibly irrigation and other treatments and things like that. So it makes them very difficult to use. A number of the pest insects have developed resistance to organophosphates, particularly in the mites and the aphids and to some extent in the thrips. And very few of them actually have enclosed structure greenhouse on the label, partly because they're older materials, partly because they have a pretty high worker hazard issues, and so I think they've just never gone there with these products. And so you're really limited to measure all in terms of enclosed structures. So that makes these particular chemicals fairly difficult to work with, but I think they're still very important for the outdoor nurseries because they're cheap and they still work really well on certain pests. And especially with invasive pests, when we get new pests into a region, they usually don't have resistance. And some of the older chemicals work fast, they're cheap, and they work well. So I think it's really important to maintain these labels and these uses, even though they can't be used in an enclosed structure. There's another group of pesticides. The previous group, I forgot to mention that I have both carbamates and OPs on here, and notice that the chemical group is 1A and 1B. The number is what you're focusing on. They're all ones. And so if you're treating with any one of these, and then you follow it up with another one from this table, you are selecting for resistance, cross-resistance between the carbamates and the organophosphates, and that should be avoided at all costs. So everything on this table is all in one group. let's go on to the pyrethroids and the pyrethrins. These are all chemical group 3, and similar to the first table that I showed you with the miticides, you have some products that are useful for bearing, and you have some products that are useful for enclosed greenhouses and some sort of in-between, but you need to be looking at those labels very, very carefully. So, and I would just say that the pyrethrins relative to the pyrethroids are synthetically developed. The pyrethrins are sort of natural, but then they often add piperonal butoxide, PBO, in order to synergize them. In general, this group is much more persistent than this group. The pyrethrins last hours to days. The pyrethroids, some of them can last many, many weeks. With glassy wing sharpshooter work that I did, we treated citrus trees and it was killing sharpshooters for up to 10 weeks easily. And so I think the pyrethroids are really important for us in exotic pest management because they're usually highly active against especially things like sharpshooters and psyllids, and they're fairly persistent as foliars. And so I think they're really important tools. So one of my comments later on will be that be careful you don't use and abuse these for your common pests because you're going to need them for the exotic pests as well. Then we have the group 4, which are the neonicotinoids, and these are being used here, there, and everywhere in agriculture and urban situations. We've got imidacloprid, which was originally Admire Pro, and now there are many, many generics, of which I couldn't even count them all. Neonicotinoids are great because they have short reentry intervals. Again, some of them can be used on bearing. Some of them can be used in greenhouses, but not all. You know, you have to look closely to see if the label actually says greenhouse. And I'm very concerned that these products, especially the systemics, are being used heavily because they have nice long persistence. But that adds to selecting for resistance. So one of the things we recommend in growing orchards is not to use neonicotinoids as foliars, only use them as systemics because you would be doubling up and really adding to that resistance by loading up the inside of the tree with the systemic material and then adding it onto the foliage at the same time. But I think, again, these are incredibly important tools, especially when we have to treat plants to ship from quarantined areas to non-quarantined areas to make sure that they're well protected for a long period of time. And then we have a whole bunch of other categories. This particular table has many different categories in it. We've got insect growth regulators in the 7 chemical group, the 15 group, the 16 group, the 18 group. We've got pymetrazine is a 9, Bacillus thuringiensis or BT is an 11. So we've got all these different chemistries, and one of our issues is some of these newer chemicals really don't have greenhouse registration. So again, look very, very closely. Micromite's great for bearing trees and non-bearing trees, but it's not specified for nurseries or greenhouse. Pymetrazine, in contrast, is not registered for bearing citrus, but it is registered for non-bearing fruit trees, and it's got an enclosed structure label. So here's a product that my citrus growers don't even know about that you have access to in the nursery situation. So study the labels, get to know these different chemical categories, and know that you have opportunities to use some pesticides that the citrus growers do not have. There are many, many different types of oil, many, many different types of soaps. They don't categorize these with any particular chemical group or resistance management group. They feel pretty strongly that it's very difficult for insects to develop resistance to these particular products. Unhappily, they don't last as long as many of the other products, but they could be applied frequently, and so they can be a really important management tool, soaps and oils. And then gradually, some of the chemical companies are starting to get on the mixture bandwagon, where they mix 2 insecticides from 2 different chemical categories together And I think there are pluses and minuses to that. My personal feeling for field-grown citrus, mature citrus, orchards is that I don't recommend mixtures because often they reduce the rate of one or both of those insecticides when they combine them together. And I would rather hit the insect with a high rate once in a while and change it up on them than hit them with a low rate of two chemicals at the same time. So that's my basic concern there. But I think they could possibly be really important tools for certain insect pests down the road, and I think we need to be studying those. Now, they don't have registration for enclosed structures at the moment, but a lot of these products are still evolving their labeling and figuring out what their fit is in the citrus system. Okay, let's talk just a little bit quickly about what groups of pests do these particular chemicals control. The carbamates and the organophosphates are very broad spectrum. They're going to kill scales, caterpillars, thrips if they don't have resistance, and katydids and earwigs. So just sort of very general broad spectrum chemicals. Similarly, the pyrethroids and the pyrethrins and the neonicotinoids are also fairly broad spectrum. The neonicotinoids tend to kill the sucking insects, but they can also get leaf miners as well, and thrips, which are not considered sucking insects. So broad spectrum, going to kill most insects. Some of the narrow target insects are much more specialized. For example, the insect growth regulator pyriproxyfen works best against armored scales and whiteflies. This new product, Endeavor, it works best against aphids and whiteflies. BT is exclusively a lepidopteran material. Diflubenzuron, I think in your system, is going to be primarily leaf miners. Buprofezin, as an insect growth regulator, primarily armored scales and whiteflies. Intrepid is primarily lepidopteran insect pests. Movento or Contos will affect armored scales. It's fairly broad spectrum chemical. Mites, leaf miner, and aphids, and do some thrips suppression. Altacor or Rynaxypyr is primarily aphids and Lepidoptera. And then the neem type, azadirachtin type materials, whiteflies, aphids, and Lepidoptera. And then the oils and soaps tend to get the smaller mobile insects, things like aphids and mites and whiteflies. They tend to get those the best. So there are differences in what's going to control what within your greenhouse situation. And then the mixtures are designed to be fairly broad spectrum and hit lots of insect groups. So let's go on to issue number 2. You have treatments for quarantine pests, things such as red imported fire ant, Asian citrus psyllid, glassy winged sharpshooter, Diaprepes root weevil, and you may or may not have experienced any of these yet, depending on where you're located in the state of California. And that creates a lot of sort of chaos in terms of treatments and regulation, because you have to treat to prevent the spread of this insect pest. And you may not even have it in your nursery, but you have to treat anyway because you're in a region that has it and you might have it in your nursery. So that adds an extra layer. The Diaprepes root weevil is found in portions of San Diego, Orange County, and Los Angeles counties. And happily, it's not moving very fast, pretty slow moving animal. We think it got sort of embedded into those regions in fully grown horticultural ornamentals that were planted in people's landscaping. And it's gradually spread, but it is near some citrus nurseries. And so those citrus nurseries are currently on a voluntary program of treating as if they have Diaprepes, so that if they were to find Diaprepes in their nursery, they wouldn't be shut down, slowed down, stopped, because their plants are already pre-treated. The red imported fire ant is found in portions of Orange, Riverside, and Los Angeles County, and nurseries are treating for that particular pest. Glassy winged sharpshooter is found as far north as Fresno, and then it jumps up to Santa Clara in portions of the state, and treatments have relaxed considerably, but nurserymen are still treating host plants to make sure that they're not shipping glassy winged sharpshooter eggs somewhere else in the state and creating new infestations. And so now we have Asian citrus psyllid. So when I first started my job, the first 10 years, there were no new pests. Now I'm seeing like a new pest in citrus about every other year. And I think this is going to continue to happen, and I think it's going to continue to be a struggle to manage all these pests. And I think you have to be really aware of these quarantines and be protecting your stock as you ship it out. So let's talk a little bit about Asian citrus psyllid. Most of you are familiar with the fact that the quarantine extends about 20 miles around any find site. And so we have portions of Riverside and San Bernardino, and then some counties where the entire county is included in the quarantine. Any citrus plants that are shipped in here have to be pre-treated because we're trying to avoid the mistake that Florida made of shipping plants around the state totally uncontrolled with psyllids riding on them. And we know that homeowners don't always understand that they're in a quarantine area and that they can't move plant material. So the safest thing to do is have the wholesale nurserymen treat the plants. The plants arrive at the retail, pre-treated, loaded with pesticides. So if a psyllid were to land on that plant, it couldn't establish. And then if a homeowner does buy the plant and drives it up to San Francisco or wherever, they're not likely to be carrying with them an Asian citrus psyllid. So therein lies the rules for bringing plant material into quarantine areas. And then out is, for obvious reasons, you could potentially have a psyllid infesting your plant material, and you need to make sure you're not moving it. So very strict regulations on treatments. And this is posted on the web, and it explains that every one of the nurserymen has to treat with a foliar and a systemic before they can move their plant material in or out of quarantine regions. And the systemics are primarily the neonicotinoids. Unhappily, we don't have more systemics than this. Movento, you could say, is systemic, but it's applied to the foliage, so I think it's been included in the foliar group. These last for several months, sometimes longer than 3 months, depending on rate and the size of the plant and when they're applied. And then the foliars are expected to last more like 30 to 60 days. Okay? And there are more variety among the foliars because we have pyrethroids and organophosphates and carbamates and this tetronic acid inhibitor that help function to protect the plants. Now, one of the issues that came up over the last couple of years is that Florida plants their plants in these citropots, and pretty much their whole industry is oriented around that citropot size. And because they have a lot of Asian citrus psyllid and a lot of Huanglong Bing, they were anxious to have the highest rate possible in the pots, protecting the plants so that when they're planted outdoors, they're like pre-protected and very low likelihood of them having psyllids or having had disease transferred to them in any way, shape, or form. So Bayer worked with the Floridians, and they looked at different rates of the Admire Pro in these pots and found that at a really high rate, it would actually stunt and harm the tree. But at lower rates, the seedlings would do fine, the small trees. And so they worked to raise the rate in order to protect Florida citrus from the Asian citrus psyllid, because concentration is everything in terms of a systemic and the psyllid feeding on the plant. But what they didn't realize is that as part of our regulations in California, nurserymen are required by law, when they're treating a plant to ship it in or out of quarantine areas, they're required by law to use the maximum label rate. And so Admire Pro now has a maximum label rate, which is quite a bit higher than the generics, like 10-fold higher. So of course the expense is really high, and we have varying sizes of pots. We have huge 5-gallon pots, and we have these little citropots, and so you go to a huge 5-gallon pot and you do maximum label rate, and you have to do it per 1/10 of a cubic foot. of course, the cost is extremely high relative to what it was before. And there's still a fair amount of uncertainty about how much exactly you have to get into the pot to get into the treat to protect the psyllid and for how long. And so one of the things I see people doing is using some of the generics at this point because the label rate, maximum rate is lower. So this little chart shows that the generics do it per cubic foot, and they vary in the amount depending on the formulation and the percentage of active ingredient within that generic product. Whereas the Admire Pro label is per tenth of a cubic foot. So just to make you aware, read your labels carefully. Know the information. So one of the final issues that I wanted to raise, I feel like I'm here to bring you your awareness level up about how you manage pests in citrus, is that for many of these quarantine pests, you're required to treat with certain pesticides before you ship. And predominantly, those pesticides are the pyrethroids and the neonicotinoids. And nearly all of these labels have maximum use rates per season. And so if you're using them for common pests during the season, and you get to the point in time where you need to ship plants in or out of the quarantine, and you need to treat those plants for these specific pests, you may not have available those chemicals anymore because you've already used the maximum amount for that season. So be very, very aware that quarantine pests are best controlled with these long-lasting, broad-spectrum pesticides, and you better be careful not to reach that limit during the year for your common pests, or you won't be able to use them for your quarantine pests. And I'll just finish with, obviously, you are looking as nurserymen for something that is efficacious, something that is cost-effective, but now you also have to be very, very aware of the regulatory issues, that greenhouse use must be on the label, invasive pests have specific treatment requirements in order to ship plants, and many insecticides have maximum use limits. And you also need to be very aware now of resistance management because the number of treatments per year is escalating, and you will end up with resistant pests, which will be very difficult to control. Are there any questions? Sure. The question was, could I add charting to either my website or the information I put out on the differences between the oils? There's different distillation points, and the higher you go up, the more they kill pests, like from a 14 to a 455. 455 is going to kill more pests, but it can also be more phytotoxic. But then companies are gradually making these chemicals purer and purer with fewer and fewer sulfonated residues. And so in the old days, a 440 oil could easily injure a tree. Now these new 455 oils that are highly pure don't injure. And we need to do some research, especially in greenhouse situations, because oils can be great for some of these pests if you apply them frequently. We need to understand, can young citrus, tolerate frequent applications of oil? I think that's a really important research question to answer. So, good point. I think originally it was listed as a systemic, and we keep going back and forth. It's not quite as persistent as imidacloprid, and that may be why it shifted towards the foliar group. But I think what you're leading at is if we always depend on imidacloprid or neonicotinoids for systemics for our indoor situations and our outdoor situations, we're just asking for resistance and breakdown and use of that product, and we better have other products to bring alongside and to depend on, because imidacloprid doesn't work in every situation. I want you looking at the labels. But this particular video is going to be available on a website for this conference, so you'll be able to refer to the presentation for the information. I'm not likely to post this specifically on the web. The question is, does the CRB core funding I get to do the sort of outdoor citrus work cover the nursery work adequately? And I would say no. I also need some funding from the Citrus Nursery Group Board to direct some of my energy towards specific issues within the citrus nursery. Some of the stuff I can extrapolate, and I can say, well, what I've seen works outdoors are these compounds, and they're going to work indoors too. But especially as you move into greenhouse structures, we need to understand better issues like, can we do repeated oil treatments? Can we, these fogging systems seem really, really interesting. We need to see what pests those specifically work on. And so I would say, yeah, I do need additional funding to focus my efforts as in the nursery industry as well. Yeah, the question is, can you test the plants to see the level of imidacloprid over the long term in the plants? And Frank Byrne will be addressing that in his talk. And so ask him that question because he's the expert on doing that. Yes, the short answer is yes, it can be done. Earwig baiting. Okay, where are we at on that one? I've just started working with earwigs. I've screened a whole bunch of chemicals. They're really hard to kill. They're like cockroaches. It takes a hammer to kill them. The only thing that kills them fast is lorsban. The pyrethroids will get them eventually. But there is one bait called seduce ant bait, or seduce earwig bait, sorry, that is like a pasta that has spinosad embedded in it that is very attractive to them if it's in the right place at the right time. So I'll be doing research over the next year to figure out when are earwigs active, when are they feeding on that type of bait system, because it seems like their feeding habits change from foliage to insects to whatever. They don't stay the same year round. And hopefully I'll have some more information for you next year on how to manage earwigs. Okay?
Thank you, Beth.
Thank you.